Hello, how are you? Welcome to the CurioClips channel. Earth 3 billion years ago. It's a world we have only glimpsed it through ancient rock formations and fossils from the earliest days of life on our planet. But what was it actually like? What would you have seen, heard, smelled if you had been there? And how did this world eventually become the one that we know today? In this video, we are going back to the start of Earth's history before the formation of complex cells or even single-celled organisms. We'll be exploring a time when our planet was very different from how we know it today and discover the major events that happened during the period known as the Archean. So let's jump in. First things first, let us talk about the climate because you definitely wouldn't want to have been outside during this time. With an average temperature of around 65 degrees Celsius, Earth was significantly warmer than it is today. And that's not even taking into account the greenhouse effect, which was much stronger back then due to higher levels of carbon dioxide in the atmosphere. Temperatures may have reached up to 90 degrees Celsius. On top of that, volcanoes were extremely active, spewing lava and smoke into the air. So if you were on Earth 3 billion years ago, you would have been met with the sight of bubbling lava lakes and the smell of sulfur and other volcanic gases. Some scientists think that these high temperatures may have even played a role in the origin of life itself. After all, some of the earliest evidence of life dates back to rocks from this period. Could the heat have provided the necessary conditions for life to emerge? It's possible. Speaking of life, let's move on to the next point, which brings us to the continents. The Earth's crust had cooled enough for solid rock to form, but these were much smaller than the continents we know today. Instead of the 7 large continents we have now, Earth was dotted with small continental masses, some no larger than a few hundred square kilometers. These land masses acted as nuclei for future continents. Over millions of years, more rock piled up on top of them, gradually forming the continents we know today. Okay, so now that we've established the basics, let's paint a picture of the world. Imagine vast oceans teeming with life and stretching as far as the eye could see. Okay, imagine this, except the water is green. That's because the oceans were rich in dissolved iron. Iron is the 4th most abundant element in Earth's crust, and when exposed to air, it reacts with oxygen to form iron oxide, which gives it a rusty color. This green tint would have been especially pronounced during storms when waves crashed against the rocks. This would cause even more iron to be released into the ocean. The surface of the water would have been constantly churning as strong winds whipped across the planet. If you took a closer look at these waters, you would have seen tiny organisms floating around. Bacteria, the first life forms on Earth. These bacteria were photosynthetic, meaning they used sunlight to make their food. But instead of using water as a source of electrons, they used hydrogen sulfide and other chemicals that were present in the environment. In fact, the Archean is named after the Greek word for ancient or archaic, and it covers the period from the formation of Earth to the emergence of the first complex cells, also known as eukaryotes. This means that for the vast majority of this eon, the only living things on Earth were single-celled organisms like bacteria. However, certain types of bacteria known as cyanobacteria would change everything. They used water as their electron source, which meant that as they photosynthesized, they released oxygen as a byproduct. This discovery has led to the theory that Earth's early oceans may have been green due to the presence of iron oxide formed by the reaction between iron and oxygen. The accumulation of oxygen in the atmosphere would have a profound impact on the planet's history, setting the stage for the evolution of complex life. You see, the oceans weren't just teeming with microscopic bacteria, they were also full of structures formed by colonies of photosynthetic microbes called stromatolites. These structures formed as layers of microbes grew and died on top of each other, creating layered mounds that can be found in shallow water environments. Stromatolites are still around today, but they were especially abundant during the Archean. Studying them helps us understand how early life on Earth functioned and contributed to shaping our planet's environment. And speaking of shaping our planet, it's time to talk about the atmosphere. You're probably thinking what I'm thinking. Where's the oxygen? You see, the atmosphere of Earth 3 billion years ago contained very little oxygen. Instead, it was mostly made up of nitrogen, carbon dioxide, water vapor, and small amounts of methane and ammonia. This would have created an orange sky due to the absorption of blue light by the atmosphere. The lack of oxygen would have made breathing impossible for most modern animals. And here's another interesting fact. there was no ozone layer either. This is important because the ozone layer acts as a shield, protecting life on Earth from the sun's harmful ultraviolet radiation. Without it, the Earth's surface would have been bombarded with UV radiation, making it even more inhospitable for life as we know it. So let's recap. The Earth was hot, the skies were orange, the oceans were green, and the continents were tiny. But despite these harsh conditions, life found a way to not only survive, but thrive. During the Archean Eon, our planet went through some major changes that set the stage for all the amazing stuff that came after. The appearance of photosynthetic bacteria, the production of oxygen as a byproduct, the formation of the ozone layer, the accumulation of oxygen in the atmosphere, the rust-colored oceans due to iron oxide, and the presence of stromatolites. All of these factors shaped Earth into a habitable planet for more complex life forms. But wait, there's more. Toward the end of the Archean Eon, something truly remarkable happened, the Great Oxidation Event. This was a period when the amount of oxygen in Earth's atmosphere increased dramatically, leading to a significant shift in the planet's environment. Before this event, the atmosphere had very little oxygen, but afterwards, its concentration rose to around 10%, much closer to the levels we have today. Now, while the Great Oxidation Event is a fascinating topic, it deserves its own video. So stay tuned because we're going to explore this phenomenon in detail in the next chapter. Before we wrap up, let's answer the question, why should you care about the Archean Eon? Well, understanding the history of our planet and how life evolved over billions of years helps us appreciate the incredible journey that has brought us to where we are today. It also provides insights into the forces that shaped Earth's environment and the delicate balance that sustains life. By studying the past, we can better understand the challenges and opportunities that lie ahead. For example, we know that the Great Oxidation Event caused major changes in Earth's environment and led to the emergence of complex life. But it also had negative effects, such as causing mass extinctions of anaerobic organisms. Similarly, we need to consider the impact of human activity on the environment today and strive to find a balance that allows for both progress and sustainability. If you enjoyed this video, please hit the thumbs up button. It really helps us grow. Also, don't forget to subscribe to our channel to get notified of new videos. Let us know in the comments below what you found most fascinating about Earth 3 billion years ago. Was it the hot temperatures, the bacteria-filled oceans, or the orange skies? We'd love to hear your thoughts. Thanks for joining us on this journey through time, and we'll see you next time. Thanks for watching.